Greetings everyone, this is Mr. Mull. This is part 3 in my stoichiometry video series, and we're going to look at today in this problem going from grams of one quantity to grams of another using that balance equation. So first step, again, we're going to need to make a balanced chemical equation and figure out what our knowns and unknowns are. So it says how many grams of potassium chlorate, KClO3, must be decomposed. Well, there's a clue of what kind of reaction it is. So decomposition, I'm going to go ahead and take my KClO3, and it says we're decomposing it or breaking it down to produce, and they even give me the products, KCl and O2. Once I've written my equation now, I need to balance it, so I'm going to go back and I'm looking, I see 3 oxygen on the left and 2 on the right. I have this even-odd situation, so we need to get to a common denominator. I'm going to get to an even number and make this 6. So make that twice as big, so I need 3 of these. That's going to balance out my oxygen, and then I'm going to put a 2 out in front here. 2, 2, 3. Okay, I'm going to go ahead and underline these coefficients because they're going to be so important to us. Alright, now I need to take my known and unknown quantities. Now, I want to clue you in here that as we're going through these types of problems, realize that the starting quantity could be any of these. Could be any of these, whether products or reactants. It doesn't matter. The recipe is the same regardless of what we start with. So I'm going to go ahead and look, and it says how many grams of potassium chlorate. So how many, question mark, grams of KClO3, that's what we're looking for, must be decomposed to produce KCl and 46.4 grams of O2. So I'm going to write 46.4 grams O2. Now what I want to focus on in this sort of example is for all these problems we need to worry about significant figures. So just looking at the only significant figure involved in this is going to be that 46.4. That's going to be our only number here, our starting quantity. So there's 3 sig figs here. All of these are really easy. They're multiplication division problems, so we have to worry about just the lowest number of sig figs. So my answer is going to have 3. Alright, so what we need to do is we need to map out a plan for how we're going to get from grams of O2 all the way over to grams of KClO3. Now, can we convert from one quantity to the other? We can, but we must use the mole-to-mole ratio of the balance equation. So that implies that we need to convert to moles before we can use that mole-to-mole ratio. So I'm going to go ahead and work backwards, and we're going to go from grams to moles of O2. And once I get to moles of O2, I'm going to get to moles of KClO3. Okay? And that's going to, remember, we're going to use our mole-to-mole ratio. Okay? Mole to mole. And then I'm going to go from there back to grams. So a couple more steps now. I'm going from grams to moles, from moles to moles to moles to grams. So we're going to take our starting quantity, 46.4 grams of O2 over 1. And I need to first convert that to moles before I can use that mole-to-mole ratio from the balance equation. So I need to get to moles of O2, and I want to get rid of grams of O2. Well, now I'm at a problem because I need to figure out how many grams there are in 1 mole of O2. So oxygen, I have 2 of those. They each are worth 16 grams per mole. So the molar mass of O2 is just going to be 36.0 or 32.0 grams per mole. So I'm going to use that molar mass in 1 mole of O2. There's 32.0 grams, just rounding to 1 decimal place. Alright, first step, I converted to moles. Now I can use the recipe. Now I can use the balance equation. So I'm going to go ahead and I want to get rid of moles of O2, and I want to convert to the quantity I'm trying to get to, and that's KCl3, but first we have to get to moles. KClO3. So now I'm going to find how those are related. And look at my recipe. For every 2 moles of KClO3, I can produce 3 moles of oxygen. So it's a 2 to 3 relationship. Now I'm here. Last step, we're going to go from moles to grams. So I want to get rid of moles of KClO3, and I want to get to grams of KClO3. So to do this, I need another grams to moles. Always remember, we need the molar mass. So I'm going to go find the molar mass of KClO3. I'm just going to write this work over here. Okay, there's one K, there's Cl, and there's oxygen. Now I'm going to have to worry about those subscripts again. So K, I look it up in my periodic table, rounded to 1, 39.1. Chlorine is 35.5. Oxygen is 16.0, but we have 3 of them. That's going to be 48.0. So we add up all of those, and the molar mass is going to be 122.6 grams for every 1 mole. So now I can use that as a conversion factor. For every 1 mole of potassium chlorate, it's going to have a mass of 122.6 grams. And now I've converted from grams of one to grams of the other, always remembering that we must go through the moles. So I multiply everything across the top, divide everything across the bottom, and I'm paying close attention that the sig figs at the beginning are going to be my determiner. I have 3 sig figs there, so I'm going to round my final answer to 3 sig figs here. Grams of KClO3. Final answer. So it really doesn't matter what we start with or where we're going. We can just convert from one to the other as long as we use the multiple ratio. And I hope that this was helpful.